diabetes, you have to talk about the pancreas. So let's take a look at a real human pancreas, and just to orient you, we're going to be looking in from the left upper abdomen. So you can see coming in from the left side here, here's the liver, we'll reflect that away, and then you can also see the stomach here, we'll reflect that, and posterior or behind the stomach, you can see how amazing this pancreas is. Now, this is the head of the pancreas, the body, and then moving on to the tail down here, and I can lift that up so you can see that a little bit better. Now, the pancreas is amazing for multiple reasons, but one of the cool things about it is that it is both an endocrine gland as well as an exocrine gland. Endocrine glands secrete hormones into the bloodstream, but the exocrine portion, if we were to look at this or look at it under the microscope, we'd find clusters of exocrine cells that will produce pancreatic enzymes, and those would be secreted into the small intestine, specifically the duodenum right here, and that's going to help aid in digestion. But the endocrine portion of the pancreas is where we're going to focus on. We'll talk about the exocrine pancreas in another video. But the endocrine portion, or those endocrine cells within the pancreas, those are going to produce various hormones and secrete them into the bloodstream. And one of the main hormones that we're focused on in this case is insulin. Now, insulin has various functions, but the function we're going to mostly focus on is that insulin lowers blood glucose levels, what many simply just refer to as blood sugar levels. Now, we need to go into a little bit more detail on how this insulin applies to the different types of diabetes, and in order for us to do that, we're going to utilize my whiteboard picture. So full disclosure, I technically traced this pink pancreas as well as the first part of the small intestine. When I don't trace things, you guys get stuck with me creating human cells that look like smiley faces, but for our purposes in this diagram, this will suffice, but you can totally tell the outside of this is representing the cell membrane, and we even have surface receptors here. These green receptors are representing insulin receptors, which will be important in just a second. So when we eat or ingest carbohydrates, our digestive tract will break that down, and eventually those carbs will get absorbed into the bloodstream as glucose. And we have a blood vessel represented here, and these black dots are representing glucose molecules, which contribute to the blood sugar levels. Now, the pancreas, in response to those blood sugar levels increasing after the meal, will release insulin, and insulin's represented in this blue triangle. This will get into the bloodstream, and so the insulin can then circulate and go to the various cells throughout the body. And the insulin will bind to these insulin receptors and essentially will tell the cell this. Eat the sugar, or in other words, take the sugar in, and the cell obliges, and that glucose goes into the cell. So you can see how insulin would therefore lower the blood sugar levels by getting the sugar to go from the bloodstream and into the cells. But what does this have to do with diabetes? Type 1 diabetes, which is also often referred to as insulin-dependent diabetes, and that's because the pancreas is no longer creating insulin. We get this autoimmune destruction of the beta cells, and the beta cells are the specific cell type within the pancreas that actually creates the insulin. So we no longer get this insulin and no longer can create this effect at the cell, and so you can see we are not going to be able to shuttle that glucose from the bloodstream and into the cell, and we might as well fix this part of the picture as well. Get this unhappy cell here. Now, with type 1 diabetes, it actually only accounts for about 5 to 10% of the overall cases of diabetes. And it typically happens in children and sometimes into early teenage years. It can also sometimes happen later in life, but most commonly in the younger years of life. Now, what's interesting is we are going to talk about potential risk factors or things that you could do to reduce your risk of getting diabetes. With type 1 diabetes, we don't get a lot of control with that. Remember, I mentioned this autoimmune destruction of the beta cells. So we're essentially getting this combination of genetics and bad luck, which is causing type 1 diabetes. However, that is a bit different when we talk about type 2 diabetes. But before we go into the details of type 2 diabetes, I want to take a second to say thank you to the sponsor of today's video, Athletic Greens. Athletic Greens is a nutrition company that makes food. One is that it can help support performance during exercise, as well as aid in recovery, as well as 5 free travel packets. Have its effects on the cell, still is actually producing the insulin. That link in the description below. So back to type 2 diabetes, which is also often referred to as non-insulin dependent diabetes. And that's because the pancreas still is actually producing the insulin. So in other words, we do have this insulin here. Let's get that back in there. And so therefore, insulin will still continue to have its effects on the cell here. It's just in the case of, if I can draw that triangle in there, in the case of type 2 diabetes, what happens is that the cells actually become insensitive or resistant to the effects of insulin. So we have this insulin trying to get the cell to take in the glucose, and the cell might do something like this and say to the insulin, which is not very nice of the cell. But you can see that because of this, we get a very similar result that we saw in type 1 diabetes, and that is the blood glucose levels will increase and get too high. Now, what's interesting about type 2 diabetes, in the initial stages, the pancreas will actually secrete more insulin or almost overcompensate in efforts to almost kind of think of it as trying to wake up the cells, especially with our cartoon drawing here. You could think of it as trying to convince the cell to take the glucose in if it pushes it with more insulin. But over time with diabetes, especially type 2, if it's not well managed, the pancreas will eventually start to wear out, if you think of it that way, and will not be able to secrete as much insulin, to the point where if this continues and someone doesn't manage their type 2 diabetes well, they may have to start taking insulin, similar to what someone with type 1 diabetes would have to do. But back to this whole idea about this insensitivity or this resistance to insulin. What is causing this? Well, we're going to find that there are some things that you don't have any control over, but some things that you do have some control over. So the risk factors that we don't have any control over mostly center around genetics. So things like family history and even certain ethnicities have been shown to have a higher risk of developing type 2 diabetes. So for example, say you had a first-degree relative, so a parent or a